Hi everyone. Today we are going to do 3.2 angles and parallel lines. Excuse me. So after today's lesson you should be able to use theorems to determine the relationships between specific pairs of angles. Alright, so the next two slides have a bunch of different theorems and postulates. So I'd like you to hit pause and actually take a few minutes to put these on your little theorem sheet. So that's the first one. And then here's the second slide to put stuff on. So hit pause again, take a few minutes and put this on your sheet. All right, so let's take a look at some examples now that you've got the addition to your theorem sheet. So we have these two parallel lines cut by this line that we call a transversal. And suppose that the measure of angle 8 is equal to 105. We need to find the measure of angle 2. So just like before with the other problems, we're going to put in our given. And in this case, we have given that the measure of angle 8 is 105 degrees. And we are going to prove or find the measure of angle 2. Okay, first things first, in statement 1, we're going to say the measure of angle 8 is 105 degrees, and our reason for that is that it's given. The measure of angle 1 is 105 degrees. Okay, and this is because of the corresponding angles postulate. Then step 3, say angle 1 plus angle 2 equals 180 degrees. And that's the definition of a linear pair. Then I know that angle 1 is 105 degrees. That's substitution. Okay, so from here, now I'm going to get angle 2 by itself, so I'm going to subtract 105 from both sides. So then I get angle 2 is equal to 75 degrees. And why is that? That's the subtraction property of equality. And Miss Overly just shared with me that she's been sharing with you guys that at the end of a proof to put a little symbol. So here's my little symbol for you that we are done proving or finding the measure of angle 2. So let's go on to another one. So we have this diagram of a map, and in there we're told that angle 1 is equal to 100 degrees, and we're going to find the measure of angle 4. So just like before, we know what's given is the measure of angle 1 is 100 degrees. And we need to prove or find the measure of angle 4. Okay, again, so statement 1, the measure of angle 1 is 100 degrees. And again, that's given. Measure of angle 1 is equal to the measure of angle 2 because of alternate interior angles. The measure of angle 2 is equal to 100 degrees, and that's for substitution. And I reflected it as well. I just put the 100 obviously over here on the right hand side. So from here, angle 2 plus angle 4 equals 180 degrees. And just like the last one, that's the definition of a linear pair. Okay, and again, just like the last one, I'm going to say 100 plus angle 4 is equal to 180. And that's substitution. And then just like the last one, we want to get that angle 4 to be by itself. So I'm going to subtract 100. And I get angle 4 is equal to 80. And that is the subtraction property of equality. All right, last example. So again, we have these two parallel lines cut by the transversal, and we're told that the measure of angle 2 is 4x plus 7, and the measure of angle 7 is 5x minus 13, and we need to find the measure of, or excuse me, find the value of x. So again, we are given measure of angle 2 is 4x plus 7, and the measure of angle 7 is 5x minus 13. Oh, that's really bad, 5. Sorry, we need to prove or find the value of x. All right, so again down here for our statements, we have the measure of angle 2 is 4x plus 7. That's given. And the measure of angle 7 is 5x minus 13. That is also given. So from here, I know that I can put 4x plus 7 is equivalent to 5x minus 13. And that's alternate exterior angles. Okay, so from here then I'm actually going to subtract 4x from both sides, and I get 7 equals x minus 13. That's the subtraction property of equality. And then from here, I need to add 13 to both sides. So then I get 20 is equal to x. And then this one is the addition property of equality. There you have it. Okay, so from here we used different theorems to help us figure out the measurements of different angles.